So we know this is concave up because of the positive 1 in front, right? And the axis of symmetry is going to require us to use our formula, which is negative b over 2a. Hopefully you've memorized that at this point. So axis of symmetry, remember it only finds x. So negative b all over 2a. So the b value is going to be negative 1. So there's a negative here and a negative in front of the 1. So make sure you account for both. Over 2 times a is positive 1. So a negative times a negative is a positive. 2 times 1 is 2. Therefore, our axis of symmetry is x equals 1/2. The vertex requires that we plug 1/2 back into the function and solve for y. So if we do that, so we have x equals 1/2. What does y equal? We put it into 1/2 quantity squared minus 1/2 minus 2. It's totally fine if you want to work with decimals. So I know that 1 squared is 1 and 2 squared is 4 minus 1/2 minus 2. So to make this easier, I'm going to convert it to decimals. So I know that 1/4 is the same as having 1/4, which is 25 cents, right? So we could rewrite this as 0.25 minus 0.5 minus 2. So then I can put that into my calculator a little more easily. So 0.25 minus 0.5 minus 2 gives us negative 2.25. So that means our y value is negative 2.25. Our y-intercept is always the c value, which is the constant by itself. So that means it's going to be 0, negative 2. And then the x-intercepts, we have to factor to find those. Tash, stop. So if we factor, we're going to start with putting our ax squared term here and our c term here. So x squared and negative 2. And then we want to figure out what multiplies to these two terms. So negative 2 times x squared is negative 2x squared. And then what adds to negative 1x. So again, we know there's always x's. I like to write those so I don't forget. Factors of 2, again, we already know this, are 1 and 2. So we know it's 1 and 2 and 1 and 2. But we have this negative 1, so that means it has to be, one of these has to be negative, right? Also, 1x plus 2x is 3x. So if this is negative 1, are we going to use 2 minus 1 or 1 minus 2? Which of those gives us negative 1? Hopefully you selected 1 minus 2. So the 2 is negative. So let's make it negative, and then we can write it over here, negative 2x, and then 1x. So now let's factor our greatest common factor out of the rows and columns. So here we have x and 1 and x, so we can take out an x. Here we have negative 2 times x and negative 2, so we can take out a negative 2. Here we have x and negative 2 and x, so again another x. And here we have 1x and negative 2, nothing in common, so we always pull out a 1. So x minus 2 and x plus 1 equals 0. This is the factored form of the quadratic, right? But the x-intercepts require that we solve each of them. So x minus 2 equals 0 becomes positive 2, so one of them is positive 2. And the other one is going to be x plus 1 equals 0, so let's subtract 1, and we get x equals negative 1. So our x-intercepts are 2, 0, negative 1, 0. So 2, 0, negative 1, 0. Now we're ready to graph. I'm going to go backwards and start with x-intercepts. So 2, 0 is here, negative 1, 0. It's nicer that these are a little further apart. It's just a little bit easier to graph, especially on these terrible touch screens. So then the y-intercept is negative 2. The vertex is at 1/2, negative 2.25. So over a half, and then right here. Let's redo that. Negative 2, and then like right there. Shoot. I'm trying to be more precise, but it's hard, so it's okay if you're not precise either. There we go. So we went over 1/2. 1/2 is right in between 0 and 1, and then we went down 2.25. So I went down 2, and then I went down a quarter step. And then our axis of symmetry is right in the middle. And I want to reflect my y point across it. So this is what your graph should have looked like.